Okay, so hi there everybody. We're now in our next video in our grade 11 statistics and probability course or subject for senior high school students. Now we're still in the chapter 0 actually. We're still building up our way to the random variables in the curriculum guide. In this video, we're going to talk about permutations and combinations. So this is the third lesson. You can see 1.3, the third lesson from chapter 0. So the first one was all about the definitions and terminologies in probability theory. Chapter 2 is all about counting sample points. Now, before we get into that, I would want you to ponder upon this. We will get back to this in a while, right after some lessons. You can see this is what we call combination lock. In order for this to be unlocked, you need to have a set of numbers, numbers that is a combination of numbers, and then it will open up. Okay, so that is the key. Okay, so what you need is to have a combination of numbers which is arranged, and if you got that number, that set of number, you can open this lock. So again, we name this as the combination lock. Okay, and we'll just get back to it after some lessons. Okay, so again, we call this a combination lock. We will start this lesson with the permutations and combinations, but we are going to first start with permutations in particular. So what are the objectives of this batch of lessons? In this lesson, you must be able to, number one, distinguish a permutation from a combination, and we will solve counting problems involving them. Okay, permutations and combinations. Now let's get into it. Now, let's give a definition of what a permutation is. So we will call this our definition 6. An ordered selection of R objects. Imagine R to be a set of a number, an integer, a positive integer. Okay, so an ordered selection of R objects from a set A. We'll just have a random set called A, containing a total of n objects. So n is the total objects in A, and we're going to have the ordered selection from this n of only R objects, where this R is less than or equal to n, and r could be equal to 0, but r could never be less than 0. So this is called a permutation of the set A taken r at a time. So this is a permutation again of set A taken this r objects at a time. This is denoted by npr. Okay, so there are other ways of writing this NPR. We're going to show that in the last part of the video, but we're going to make use of this because this is what our book is telling us to use. So we call this a permutation. So a permutation, in other words, it can be um, synonymous to the word arrangement. So how many arrangements in the set A can be taken R at a time, given the total number of objects in A to be n. So let's give one example. If you have 10 books that you wish to place on a shelf, in how many ways can you arrange this book? So let's have that you're going to arrange all of the books. So there are 10 books. So imagine you have a shelf here, and then you want to arrange that in order. How many ways can you do that? So for example, we'll have book 1 up until book 10 of a certain novel. So book 1 to book 10. So you can put on the first part of the shelf to be book 1. It can be book 2, it can be book 3, it can be book 4, or so on. But the thing is, you have 10 choices there in the first part of the shelves. In the second part of the shelves, you only have 9 choices left because the first book is already put on the first part. And then you have 9 choices then. And then the next week we have 8 choices. And then you have 7 choices. So actually the number of choices gets less and less. So we call this 10p10 because we have 10 books and we're arranging all of them. Okay, so we have 10 choices on the first part of the shelf. We have only 9 choices left because we already put the first choice in the first part of the shelves, and then we have times 8. We're making use of the multiplication principle here, by the way, and we only have 8 here because the first 2 books are already put on the first 2 parts, and then we have 7 because the first 3 books are already put there, and we have up until times 6 times 7 times times 6 times 5 times 4 times 3 times 2 times 1 up until there's only one space left on the shelf, and that's left for the one book which is left and not chosen from the first 9. So we just multiply all of it. 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So that's 3,628,800. So this means that there are 3,628,800 ways for you to arrange 10 books in a shelf. Okay, and then you're going to arrange all of them. Okay, so we have this number of ways to do that. Okay, now this notation here is quite familiar if you have some background in some intermediate mathematics. So we can simplify this notion here by making use of what we call factorial notation. Then we're going to talk about factorials here. So in the previous example, the answer consists of the product of all the numbers from 10 going to 1. So 10 times 9 times 8 times 7 up until times 1. As values of these are common with counting and probability, so these are common in probability theory, especially in counting sample points, we have a special notation to simplify the writing of such numbers. So we will call this the definition 7. So for any integer n greater than or equal to 0, so that is the integer should be non-negative, we say n factorial, we write this n factorial as in n with the exclamation sign. So we read this in mathematics, we read this, or we call this factorial. Okay, so we read this as n factorial. This is defined by definition 0 factorial is equal to 1. Maybe I can give a separate video of why that happened. And then we have n factorial will be equal to n times n minus 1 times n minus 2 times n minus 3 times n minus 4 up until 3 times 2 times 1. So this happens for all n in the positive integers. If n is equal to 0 here, it's going to be equal to strictly 1. So just like in our previous example about the 10, so we have 10 factorial is equal to 10. This is your n. 10 minus 1 is 9. 10 minus 2 is 8 up until 3 to 1. So 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 up until 1. So going back in our previous example, we can say that 10 factorial is equal to this because that's 10 times 9 times 8 times 7 times 6 up until 1. So we can simplify that long notation into this so that writing in mathematics will be a little bit easy. Okay, so again, this is what we call a factorial notation. Okay, let's get into more permutation. So let's take a look at these examples. So suppose that you draw out 3 books from the shelf with 10 books. Imagine that shelf again. You're going to draw 3 books from there, and you need to put them in another shelf. So you're going to draw 3 out of the 10, and then you're going to put them in another shelf in your cabinet. In how many ways can you now arrange these books? Okay, now we want to think of this that we have 10 books in total, but we're going to get 3 out of them, and then we're going to arrange these 3 into another shelf. Okay, so this problem involves a permutation of 3 objects taken from a set A containing 10 objects. So we are only taking 3 objects out of the 10 objects, which is the total of this set A. Now, we have this again, NPR. This will be your R because you're taking only R objects out of the N objects, which is a total. So this is your R, this is your 10. So going back to the notation of NPR, this will look like 10P3. Now 10P3 means we only need to arrange 3 objects starting from the 10. So that will show us, or that will give us 10 times 9 times 8. Okay, so this is 10P3. So 10 times 9 times 8. Okay, 10 times 9 times 8. So that's going to be giving us 720. Okay, that's going to be giving us 720. Okay, now from this, we're going to present one theorem in permutations. So the number of permutations of length r, these are the number of objects you take from the total n that can be formed from a set of distinct elements is given by this formula. So this is our general formula for permutation. So NPR is equal to n factorial divided by n minus r quantity factorial. So that's our general formula there. Okay. So if you're going to arrange r objects taken from the total of n objects, this is what you're going to go through. So n factorial all over n minus r quantity factorial. Okay. Now let's have some corollary from that. So a corollary is a lesser another theorem. Maybe it may be a lesser theorem taken from from one original theorem. So a corollary, the number of ways to permute an entire set of n objects, distinct objects. So if you're going to permute or arrange n distinct objects, all of them, so you're going to substitute n to be equal to r. So that will show us npn. So if r is equal to n, you substitute n here. That's going to be n factorial over all over n minus n quantity factorial. N minus n is 0, so 0 factorial is 1. Hence, npn is just equal to n factorial because it will be n factorial over 0 factorial or equal to 1. So that's a corollary. Okay, hopefully that helps. So again, we have this general theorem, we have this corollary over here, and let's give some exercise. Okay, um, exercise 1. So 5 boys and 4 girls are to be arranged in a row. How many ways can this be done if, number 1, there are no restrictions? Okay. Um, so how many ways can we do this if there are no restrictions? Okay. So if there are no restrictions, so we have 5 boys and 4 girls. You may pause the video if you want to answer first. Okay, so if there are no restrictions, so our n is actually 9. 5 plus 4 is 9. So if there are no restrictions, so we have n 9p9. Okay, so you may want to use your calculators there. So what is 9p9? 9 factorial 9, that's going to give us um, 9 factorial, which is equal to 362,880. Okay, 362,880. Okay, B, the boys must be alternate. The boys and girls rather must be alternate. So it should look like a boy girl boy girl boy girl kind of scenario. Okay, so we have imagined this arrangement of boys and girls. They are alternative, being alternate. So we must have boy girl boy girl boy girl. So it will look like 5 times 4 times 4 times 3 times 3 times 2 times 2 times 1 times 1. So I will give another video for that to explain how this happens. So the boys have their own arrangement. That is 5 times 4 times 3 times 2 times 1. The girls also have that arrangement, 4 times 3 times 2 times 1. So making use of the permutation way of doing this. So we have 5p5 times 4p4. So that's going to be 5 factorial times 4 factorial. That's going to give us 5 factorial is 120. 4 factorial is 4 times 3 times 2 times 1. That's 24. So hence, we have 120 times 24, which will give us 2,880 ways to do that. Okay, so letter C, let's have this. Two particular boys, Rudy and Ali, insist on sitting next to each other. So Rudy and Ali are best friends, so they do not want to be away from each other. So it should be that they actually they are sitting beside each other. So we're going to take Rudy and Ali to be one block. Okay, we're going to take them as instead of two boys, we're going to get them as one boy. So there are only one block as boys. So there are 4 boys that will take it up and then 4 girls. Then there are 7 other people in this block. Okay. Now, since we have 4 boys and 4 girls, and there are no other restrictions, that only that Rudy and Ali insist to be sitting each other. So instead of having 9 all in all, it's going to be 8. So that's simply 8 p 8. So that's 8 factorial. So what is 8 factorial? It is 8 factorial is 40,320 ways. Okay, and here there are 7 other um, and then take note, there are only 8 factorial arrangements, but Rudy and Ali can also, change seats, even though they're in one block. So they can also change seats. So Rudy and Ali is like 2p2. So that's 2 factorial, which is just equal to 2 ways. So what we need to do is to have this, making use of the multiplication principle. So that will give us like this. So this is equal to 40,320 times 2 is going to be 80,640 ways all in all. Okay, so in the next video, I'm going to prepare um what do you call that? I'm going to prepare some paper, some online paper, some spreadsheet. Not really, not spreadsheet. That's the word. Some sketchpad rather, some sketchpad in order for me to represent these answers. So I'm going to give you again these exercises next video, and then I'm going to answer that using a sketchpad so that you can thoroughly understand it and thoroughly um, digest it. So that's it for this video. Thank you very much for watching. Hope you'd like and subscribe, and please check out my other videos in grade 11 statistics and probability. So see ya.